Hi guys, this is Divyansh Gupta, CAT 1900 Percentiler from IIMpact.mba. For your benefit, I have launched a free course for the CAT 2025 most probable questions. Check the link in description and enroll now for free. Alright folks, so let's start with the discussion of polynomials quiz. Question number 1. Graph of a quadratic expression ax square plus bx plus c attains a maximum value of 10 at x is equal to 2. Graph intersects the x-axis at 2 points, one positive and other negative. Then which of the following is our positive? So we basically will have to draw the graph to understand what is happening. So the graph is attaining a maximum value, which means that a will have to be negative, which means it will have to be a downward facing parabola. So that much is clear. You don't have a defined maximum value for an upward facing parabola. So a is going to be negative. Now the maximum value that you are attaining, it as x is equal to 2, and that value is a positive value of 10. Now the graph is intersecting the x-axis at 2 points, one positive and the other negative. So the positive one is definitely going to be on this side. The negative one will have to cross the y-axis somewhere here between 0 and 10, and then intersect on the negative side, intersect the x-axis on the negative side, which basically means that there is one negative root and one positive root. So C, which is your intercept, is going to be positive, which means that answer cannot be D. A is negative, A is not positive. Only B is also not true. C will definitely be positive, and now we only need to check for B. So this value of 2, this corresponds to minus B by 2A. And since A is negative and we want this entire thing to be greater than 0, B will have to be positive, so that this negative and this negative cuts out and you are left with a positive value. So this means that both B and C are going to be positive, which means your answer for question number 1 is C. Moving on, in the equation x minus m into x minus n minus 4 is equal to 0, m is greater than n, when which of the following is true about the roots of the equation? So they have given us options like both roots are non-real, one root is less than n, the other one is greater than m, both the roots lie in n comma m, and both roots lie in n plus 4 comma m plus 4. So the options are a bit tricky. We can write it like this: x minus m into x minus n is equal to 4, and this will immediately tell you that both of these either have to be negative or both of these either have to be positive, which means option number A is out of the picture. Because if the root lie between n and m, then one of them will be negative, which will be m, x minus m, and x minus n will be positive. So negative into positive will not give you a positive number on the right hand side. At this point, we can probably try and see option B becomes true from this argument that I just gave. However, will the roots exist or not? That is something I do have to check for. So in that scenario, might as well do the most used trick here, which is to find the discriminant. So this will be x square minus m plus n into x plus mn minus 4 is equal to 0. So your discriminant will be m plus n whole square minus 4 into mn minus 4. Now this will be m square plus n square plus 2mn minus 4mn plus 16, and this will now become m square plus n square minus 2mn, or m minus n whole square plus 4 square. So this is a sum of two squares. This is your discriminant. So your discriminant is always going to be positive, which means that both the roots are actually real. So you won't have unreal root situation. Now we only need to decide between option D and B. Option D can be eliminated based on the same reasoning that we used for A, because between n plus 4 and m plus 4 you can have situations where both of them are not of the same sign. So the answer for question number 2 is B. All right, question number 3: if x is an integer, all right, so one constraint I immediately have, then I have a cubic equation and I have to find the value of x. So I have been given only one equation, The only supporting argument that I have is that x is an integer. Now, there is no solution formula for a cubic. You can't find the roots of a cubic by putting in some formula, right? So, this is something that we should be able to factorize. And the idea of factorization is coming from the fact that x is an integer. So, whatever I factorize this left hand side to be, it is going to be an integer only because it will be a combination of x powers, and 993 can then be represented as its integer factors, 993 or whatever we end up with on the constant side. So this is x cube minus 2 times x plus 2 whole square is equal to 993. Now, in order to factorize this, I would need an x plus 2 with the cubic. So I will add 2 cube on both sides. This will give me x cube plus 2 cube minus 2 times x plus 2 whole square is equal to 993 plus 2 cube, that is 1001. Now this is going to be x plus 2 into x square plus 2 square 4 minus ab, that is 2 into x. So we just used our identity. It's going to be this minus 2 times x plus 2 whole square is equal to 1001. So now I only have to take x plus 2 common. I'll be left with x plus 2 into this entire term, x square plus 4 minus 2x minus 2 times x plus 2. So minus 2x minus 4 is equal to 1001, or I will get x plus 2. This will 4 and 4 will cancel. I will left with x square minus 4x. I will take x common. So x plus 2 into x minus 4 is equal to 1001. So the only thing now I have to do is find the value of x which will satisfy this. So now I will factorize 1001. It is going to be divisible by 11. So it's going to be 11 into 91, and 91 is 7 into 13. So this is 7 into 11 into 13, and if we put x as 11, I'll get x minus 4 as 7 and x plus 2 as 13, which means that x is 11. So answer for question number 3 will be x is equal to 11. Moving on, uh, I have factorized fifth power function on the left hand side, and I want this to be greater than equal to 0. How many single digit whole numbers value can x assume? So my answer set is going to be single digit whole numbers. So from 0 to 9. So a total of 10 values I can take. So you might feel the need to go through this with hit and trial, and I mean there are 10 values, so you can actually do that. However, if you do want to do this with a proper method, I would want to write this in the proper factor format where I have x minus something and not 2x minus something, because then when I make the cuts on the graph, I want those cuts to be at the roots, and x is equal to 1 is not the root, x is equal to 1 by 2 is the root. So because I have 0 on the other side, I can divide this on left side and right side with 2 to the power 5. So I can write this as x minus 1 by 2 into x minus 1 into x minus 3 by 2 into x minus 2 into x minus 5 by 2 is greater than equal to 0. And now I will make the cuts on the x-axis. I'll get 1 by 2, I'll get 1, I'll get 3 by 2, I'll get 2, and then I'll get 5 by 2, and then so on so forth. After 5 by 2 you will have the same sign, and before 1 by 2 you will have the same sign. So before 1 by 2 all the 5 terms will be negative, which means their product will be negative. So this is negative. After this I can alternate, so plus, minus, plus, minus, and plus. So after 5 by 2 all the whole numbers are going to be part of my answer. So 3 to 9 all the values are part of my answer. 3 by 2 and 2. So 2, at 2 I will get a value of 0, because this term 2x minus 4 will become 0, and 0 is allowed. So 2 is also part of my answer. Similar reasoning for 1, that at x equal to 1 this 2x minus 2 will become 1. So 1 is also going to be an answer. And then on this side, the last whole number, which is 0, you are getting a negative value. So 0 is not going to be part of your answer, which means from 1 to 9, all the whole numbers are going to be part of your answer. So the answer will be 9 single digit whole numbers. All right, folks. So Question number 5. The number of real roots of the equation a by x minus 1 plus b by x plus 2 is equal to 1, where a and b are both negative real numbers. So they are asking me for number of real roots which is dependent on the discriminant. So I must arrange this relationship in a quadratic format where I can then thus find my discriminant. So I will write this as a times x plus 2 plus b times x minus 1 is equal to x minus 1 into x plus 2. Now I will open all these terms and arrange on one side. So I'm taking this on the left side. I'll get x square plus x minus 2 is equal to ax plus 2a plus bx minus b, which thus becomes x square plus x times 1 minus a minus b plus b minus 2 minus 2a is equal to 0. This is your standard quadratic. Now I can find the discriminant, which will be this square minus 4 into 1 into this. So that becomes 1 minus a minus b whole square minus 4 times b minus 2 minus 2a. So now when I open this, I will use the a plus b plus c whole square property. This will become 1 plus a square plus b square plus 2ab minus 2a minus 2b minus, now I will open this term, 4b plus 8 uh, plus 8a. Now I will make a perfect square in a square. I'll get a square plus 6a plus 9. So this will become a plus 3 whole square plus b square plus 2ab minus 6b. Now, this term is positive. This is positive. A and B both are negative. So AB is positive and B is negative. So then when multiplied by a negative number, this will also become positive. So you have addition of four positive numbers, which means discriminant is positive, which means you will have two roots. So your answer for question number 5 will be C. Moving on, question number 6. If fx is a quadratic polynomial such that f of 5 is equal to 35 and f of 25 is equal to 35, and fp is equal to fq is equal to 0, find p plus q. So now a lot of people would want to, assume ax square plus bx plus c is equal to 0 and then start putting 5 and 25 and arrive at some sort of relationship. This question is best done through a graph. So at 5 and 25, you have a value of 35, which would mean that these two values, 5 and 25, are at equal distance from the are at an equal distance from the line of symmetry. A quadratic is a symmetrical function, a parabola is a symmetrical shape, and if you are having same value, it means you are at a equal distance on either side, which means whatever these roots are, let's say p and q, p plus q will be equal to 2 times this point, which will be equal to 5 plus 25. So through symmetry, you can say p plus q is going to be 30. All right. So question number 7. Two non-zero real numbers x and y satisfy the equation given below. You have x plus y plus x square plus 10y square is equal to 0. And we have x upon y plus y upon x is equal to 9. So if I manipulate this one, I will get x square plus y square is equal to 9xy. Let me now make a move on the second one. So this is x plus y plus x square plus y square plus 9y square is equal to 0. This I can replace with 9xy. So I'll get 9y square plus 9xy plus x plus y is equal to 0. All that remains to be done is that I must remove the x term now. So this becomes 9y square plus, if I take y common, 9x plus 1 plus x is equal to 0. After this, all I have to do is find the value of y. This is a quadratic in y. Let's see what happens. So the using the root formula, I'll get minus 9x plus 1 plus minus under root of 9x plus 1 whole square, which is going to be 81x square plus 1 square 1 minus, plus 2 into 9x into 1, which is 18x minus 4 into x into 9. So minus 36x. Basically, this sign will become minus and this becomes a perfect square. So my roots will become minus 9x plus 1 plus minus 9x minus 1 divided by 2 into 9, that is 18. So this is the value of y that I'm getting. So now I'll find the roots. One root will be y is equal to minus x, and the other root will be y is equal to minus 1, that is minus 2 by 18. So that is minus 1 by 9. Now y is equal to minus x is disallowed here because that would mean x plus y is equal to 0. So y is equal to minus 9, or answer is minus 27 into minus 1 by 9, or y is equal to 3. All right, moving on. Difference between the maximum and the minimum possible value of a for which this equation has real and equal roots. So basically I want discriminant for this quadratic to be equal to 0. So this will be 3x square plus, if I take x common, a minus 3 plus 12 is equal to 0, or a minus 3 whole square minus 4 into 3 into 12 is equal to 0. Now this will become a minus 3 whole square minus, this will become 12 into 12, that is 12 square is equal to 0, or a minus 3 minus 12 into a minus 3 plus 12 is equal to 0. So I basically used x square minus y square is equal to x plus y into x minus y. So this gives me a minus 15 into a plus 9 is equal to 0. So the values that I am getting is 15 and minus 9 for a. So the difference between 15 and minus 9 will be 15 minus minus 9, which is 24. So the answer for question number 8 is D. Moving on, the pair of straight lines y is equal to 2x square meet the graph of y square is equal to 4x at the origin and also at the points P and P dash, forming two closed loops. The ratio of the area of the upper loop to that of the lower loop. So first of all, let us first figure out what these lines are. Y square is equal to 2x square would be y is equal to plus minus 2x. So one line would be like this, passing through the origin. The other line will be the reflection of this line along x-axis, just with a negative slope. So these two lines are symmetrical to each other. Now the graph that I have is y square is equal to 4x, and this is a silly mistake that a lot of people could have made, that x square is equal to 4y is where your parabola is upward facing. But because now you have y square is equal to 4x, it will be something like this. Now clearly, because there is no c term here, y square is equal to 4x, there is no constant, so this will pass through the origin, and for any value of x you will get a positive y and the same y but with a negative sign. So this would also be symmetrical around the x-axis. So this is the situation. The parabola is symmetrical around the x-axis and the two lines are symmetrical around the x-axis. So these are the same two curves, this one and this one, that are reflected around the x-axis. So whatever they do on the positive side of the x-axis, basically above the x-axis, whatever they do, they will do the same thing on the other side below the x-axis. So these two areas are going to be same. So your answer will be 1:1. Moving on, fx is a quadratic equation, the roots of which are alpha and beta. F of 4 is equal to 4f of 1 and beta is equal to 3. So the equation that we will write is ax square plus bx plus c is equal to 0. Now if I put 4 here, I'll get 16a plus 4b plus c. This is given to me as 4 times f of 1, which will be a plus b plus c. So that gives me 16a plus 4b plus c is equal to 4a plus 4b plus 4c. 4b and 4b will cancel. I'll get 12a is equal to 3c, or c by a is equal to 4. Now I have one of the roots. The product of the roots of this quadratic would have been c by a, which is 4, which is beta into alpha. Now beta I know is 3, which means alpha is equal to 4 by 3, and 12 alpha will be 4 by 3 into 12, which is 16. So your answer for question number 10 will be 16. So I have two quadratic equations here, and I'm being told that they have one positive root in common. So I have to find the value of A. Now, when you have a positive root in common, let's say alpha, let's say you have a root in common which is alpha, then the standard trick in these questions is to put that alpha in the given equations. So I will get alpha square minus a alpha plus 3 is equal to 0, and alpha square plus a alpha minus 5 is equal to 0. If I add these two equations, I will get 2 alpha square minus 2 is equal to 0, or alpha square is equal to 1. Now, the root that is common is positive, so I will take alpha as 1, not minus 1. So when I put alpha as 1 in this equation, I'll get 1 square minus a into 1 plus 3 is equal to 0, or a is equal to 4. So your answer for question number 11 will be 4. Moving on. Find the quadratic equation whose roots are half the roots of the equation x square plus 5x plus 3. So there are two methods to this. Method 1, which is, recommended, slightly risky, is you have this quadratic given to you. X square plus 5x plus 3 is equal to 0. Now the root of this quadratic equation is alpha and beta. What should I replace x with so that the roots become alpha by 2 and beta by 2? So if I replace x with the 2x, let's say this is the new quadratic that I am writing. This is a new quadratic that I have made. What is going to be the root of this quadratic? You will put, if you put x as alpha by 2, you will get alpha square plus 5 into alpha plus 3 is equal to 0, which is something we know is true. So this would be the new quadratic. So your answer will be 4x square plus 10x plus 3 is equal to 0, which is option number D. The other method would be that I know that this has alpha and beta as root. So I know alpha plus beta is equal to minus 5 and alpha beta is equal to 3. Now, if I want a quadratic whose roots are half of this, so the sum of the roots will be alpha by 2 plus beta by 2, or alpha plus beta by 2, which is minus 5 by 2. And the product of the roots will be alpha by 2 into beta by 2, which would be alpha beta by 4. So these are the coefficients of this quadratic. So x square minus 5 by 2x plus 3 by 4 is equal to 0. This is going to be my new quadratic. And if I take 4 as an LCM, I will get 4x square plus 10x plus 3 is equal to 0. So the same answer. Either method is fine. This is, does not require any creativity. So you can prefer this. This one is much more faster. Moving on. Fx is a quadratic function such that f of 4 is equal to 4 into f of 1. If one of the roots of fx is equal to 0 is 2, find the second root. So I will do the same exact thing. I'll write ax square plus bx plus c as my quadratic. I will now put x is equal to 4. I will now put x is equal to 4. I'll get 16a plus 4b plus c is equal to 4 times f of 1, which is a plus b plus c, or 16a plus 4b plus c is equal to 4a plus 4b plus 4c. 4b 4b cancel. 4a will make this 12a and this will become 3c. So I will get c by a is equal to 4. C by A is going to be what? The product of the roots, which is alpha into beta. Beta I am given is 2. So 2 alpha is equal to 4, or alpha is equal to 2. So the second root is going to be 2. If one of the roots of the equation is twice the other, then which of the following can be the value of k? So let's say one root is alpha, the other root is 2 alpha, which means that alpha plus 2 alpha is 3 alpha, which is given to me as minus 3k plus 4 by 2. Product of the roots will be alpha into 2 alpha, that is 2 alpha square, which is given to me as c by a, which is 9k square minus 3k minus 1 divided by 2. So, I can square and divide. So there are a lot of things that I can actually do. So maybe let me do this only. Let me square this one, which will give me 9 alpha square. This will become plus, this will 3k plus 4 whole square, and this will become 4. I will shift this to this side. If I divide these two equations, I will get 9 by 1 is equal to 3k plus 4 whole square divided by 9k square minus 3k minus 1, which is going to be, let me just write it like this, minus 3k minus 1. 81k square minus 27k minus 9 is equal to 9k square plus 16 plus 2 into 3 into 4, that is 24k. Or I will get 72k square minus 27 plus 24, which is 51k minus 25 is equal to 0, or k is equal to 51 plus minus under root of 51 square plus 4 into 25 into 72 divided by 2 into 72. So I can find the value of k from here. So this will become 51 plus minus, this is 2601 plus 7200, which is 9801, which is 99 square. So 99 divided by 144. Now all options are less than 1, so I'm not going to take the positive root. I'll take 51 minus 99 divided by 144, which is minus 48 by 144, or minus 1 by 3. So your answer will be option C. Moving on. Equation x cube plus 3n minus 1 x square plus 12n minus 19x plus 4 has minus 4 as one of the roots. If the other roots are real and non-negative, then how many possible non-negative integral values exist for n? So the approach is clear. This cubic I will convert to a quadratic by using this as one of the factors, x plus 4 as one of the factors, after which I will apply my discriminant being greater than equal to 0, and the roots be non-negative to the quadratic that I will get. So this will become x plus 4 into, I will get x square, leading coefficient will be 1 because x cube coefficient is 1. So this will be made by 1 into 1 plus 4, or rather this will become plus 1 because I will get 4 into 1 is equal to 4. Now let me just call this as plus bx. So I will get x square coefficient as 4 plus b, which is given to me as 3n minus 1. So b will turn out to be 3n minus 5. Let me just check if it satisfies for x as well. So the x coefficient will be 4b plus 1, x into 1. So 4b will be 12n minus 20 plus 1. So 12n minus 19. So yes, the value of b as 3n minus 5 will satisfy. So the quadratic that I will get is x square plus 3n minus 5x plus 1 is equal to 0. So the roots are supposed to be real, which means 3n minus 5 whole square minus 4 is supposed to be greater than 0, which means this is 2 square. So I can write this as 3n minus 5 minus 2 into 3n minus 5 plus 2 is greater than 0, or 3n minus 7 into 3n minus 3 is greater than 0. So that would mean if I further remove the 3's in front of the n's, I'll get n minus 7 by 3 into n minus 1 should be greater than 0, which means n should be either greater than 7 by 3 or less than 1. I think equality would also be allowed because they have not said that the roots need to be distinct. So I can put equality also here. Apart from this, so right now seems to be I have infinite answers because there are infinite number of non-negative integers greater than 7 by 3. Now I will have to check for the second constraint, that the roots have to be non-negative, which means because the product of the roots is already coming out to be positive, the only thing I need to ensure is that minus b by 2a and a is equal to 1. Basically, if I quickly draw a makeshift graph, I want this point to be on the positive side. This, along with the fact that the product of the roots is positive, product of the roots already mean that the both roots have the same sign, either positive or negative, which means I only need to ensure that minus b by 2a is greater than 0, which means 3n minus 5 is less than 0, or n is less than 5 by 3. So I am getting Now this and this cannot be true at the same time, so this is ignored. This and this, if I intersect these two, I'll get this only as my answer. So the only possible value of n that I can have is 1 and 0. 1 and 0, because they're asking us for non-negative integral, so 0 is also possible. So the answer will be two possible values. All right, moving on. M and P are integers such that x square minus mx plus 4 is greater than 0. I have three quadratics here. What is the largest possible value of 3m minus 4n plus 5p? Now, this is always greater than equal to 0, which means that m square minus 16 is less than equal to 0. Similarly, if I write the discriminant for this, because it is greater than equal to 0, I will get n square minus 4 into 4 into 2, which is 32, is less than equal to 0. If I write for this, I will first, consolidate it. I'll get x square plus px plus 10 is greater than 0. So there is no equality here, which means that the discriminant will have to be necessarily less than 0 for this, which is p square minus 40 is less than 0. Now, if I want to maximize this, I would want to maximize m, I would want to minimize n, and I would want to maximize p. So if p square is less than 40, the maximum value of p, an integer, can be 6. So this is 6 into 5. If m square is less than equal to 16, then the maximum value of m that I can take is 4. So 3 into 4 minus, now n I have to minimize, I will get n square is less than equal to 32. So the minimum value of n that I can take is n is equal to minus 5. So this will become minus 4 into minus 5 plus this. So the answer will be 12 plus 20 plus 30, which is 62. Moving on. F of x is a quadratic polynomial in x such that f of x is less than equal to 0 for all real numbers of x. So it is going to be a downward facing graph, and one of the roots they have already given to me as f of 3. So 3 is one of the roots. So it's going to be something like this. Now f of 8 is minus 50, and I have to find the value of f of minus 8. So seems pretty straightforward, because I'm just touching the graph at 3. I can assume the quadratic not in terms of ax square plus bx plus c. That is not going to be very helpful. I can assume the quadratic to be a times x minus 3 whole square, because if you are having repeating roots, you will have a perfect square in your quadratic factor format. So this becomes equal to f of x. So now they have said that f of 8 is equal to minus 40, which means minus 50, which means a into 8 minus 3, that is 5 square, is equal to minus 50, or a is equal to minus 2, which means your quadratic is minus 2 into x minus 3 whole square. Now I can just put x is equal to minus 8. I will get minus 2 into minus 11 whole square, which is 121. So minus 242. Your answer for question number 17 is going to be B, minus 242. So this was a critical step. You could have gone with the x square plus bx plus c. You could have put x is equal to 3 and output is 0, x is equal to 8 and output is minus 50, but that would have been lengthy. This is much more straightforward. Moving on. If x square plus x minus 2y minus 3 whole square is equal to minus 4x plus y, then what is the value of 3x plus 4y? So I have one equation, two variables, and I am being asked an exact thing, which means, particularly there is also quadratics here, which means I am thinking about completing these squares. So I'll get x square plus 4yx plus 4y square plus x minus 2y minus 3 whole square is equal to 0, and this I can write as x plus 2y whole square plus x minus 2y minus 3 whole square is equal to 0, which means x plus 2y is equal to 0 and x minus 2y minus 3 is equal to 0. So I can write this as this. So if I add, I'll get x is equal to 3 by 2, and if I substitute that, I'll get y is equal to minus 3 by 4. Now 3x plus 4y is going to be 3 into 3 by 2 plus 4 into minus 3 by 4. So this will be 9 by 2 minus 3, which is 3 by 2. Now that is equal to x, but I don't have that as an option here given to me. So I can write 3 by 2 also as minus 2y. So your answer will become for question number 18 as D. Moving on. A quadratic has real roots such that the difference of the reciprocal of the roots is 1 by 15 and the sum of the reciprocals of the roots is 1 by 9. So 1 by alpha minus 1 by beta is given to us as 1 by 15 and sum of the reciprocal of the roots is 1 by 9. So 1 by alpha plus 1 by beta is equal to 1 by 9. So I don't really have to do much. I pretty much have been given the roots. If I add these two equations, I'll get 2 by alpha is equal to 1 by 15 plus 1 by 9, which is going to be, if I take the LCM, this is going to be 45. So 15 into 3 and 9 into 5. So that is 8, right? 3 plus 5. Yeah. So alpha is given to me as 45 by 4. I can now substitute this back. I'll get, 1 by beta as 1 by 9 minus 1 by alpha, which is 4 by 45. So I can write this as 45 and above I can write as 5. So 1 by beta becomes 1 by 45 or beta becomes 45. Now they are asking me for the value of b plus c. So minus b is sum of the roots, which is 45 plus 45 by 4. So, minus of minus b because they've already put it as minus b. So, b is equal to 45 plus 45 by 4 and c is equal to product of the roots, which is 45 square by 4. So, I just have to add these, which is going to be a task 45 square plus 45 plus 4 into 45 divided by 4 is going to be my answer. So I can quickly calculate this. This becomes 5 into 45 and if I take 45 common, this becomes 45 into 50 divided by 4. So this is 25, this is 2. So I now have to calculate 45 into 25. All I have options with 4 and 2 as well. So I'll just quickly calculate this. 5, 2, 2, 2, 2, 5 and this becomes 0, 1, 8, 9. So 5 to 1125. So this is 11225 by 2 or 2250 by 4. So your answer for question number 19 will become A. P and Q are the roots of quadratic x square minus 8x plus m has P and Q, and x square minus 72x plus n has roots R and S. P, Q, R, S are the first terms of an increasing GP, which means P plus Q is equal to 8 and R plus S is equal to 72 is going to be getting used. This P, Q, R, S are in increasing, GP. So I can write this as P times 1 plus R is equal to, or, we already have R. So I will take something else to represent my common ratio. Let me call this as D. 1 plus D is equal to 8. And here, if I take, P into D common, PD square common, I'll get 1 plus D is equal to 72. So if I divide, I'll get 1 by D square as 9 or D is equal to 3. So the common ratio is 3, which means P will be equal to 2. So the terms are 2, 6, then 6 into 3, 18, and then 18 into 3, 54. These are the four terms that I have. Now they are asking me for the value of M plus N. So M is going to be what? Product of these two, and N is going to be product of these two. So I have to find 12 plus 18 into 54, which is going to be 984. So your answer for question number 20 is 984. You could have also actually guessed the values of P and Q because P plus Q is equal to 8 and R plus S is equal to 72. So already feels like easy to find if you guess. All right, moving ahead. The value of root x minus root x and so on till infinity. So this is a standard approach. You assume this to be as x. If you square this, you will get x square is equal to 6 minus whatever is inside is actually what? Still x. So x square minus x, x square plus x minus 6 is equal to 0 is what we are getting. This can be written as x minus 2 into x plus 3 is equal to 0. Now, under root of something by convention is taken as positive. So, the negative root will not be your answer. X will turn out to be equal to 2. So, your answer for question number 21 will be C. Moving on, last question. X to the power 4 plus 1 by x to the power 4 is equal to 194, and we have to find x cube plus 1 by x cube. So, this I can write as x square plus 1 by x square whole square minus 2 is equal to 194. So this becomes equal to 196, which is 14 square. So x square plus 1 by x square is equal to 14. I will do this again, add 2 on both sides. I will get x plus 1 by x whole square is equal to 16, or x plus 1 by x is equal to 4. Now I have to find x cube plus 1 by x cube. So x cube plus 1 by x cube will be, I can cube this entire thing. I'll get x cube plus 1 by x cube plus 3 into x into 1 by x, which is 1, into x plus 1 by x, which is 4, is equal to 4 cube, which is 64. So x cube plus 1 by x cube is equal to 64 minus 12, or 52. So the answer for question number 23 is 52.